Welcome to solverfy.
All right, question 75 says that we have two colorless molecular liquids, and it's important that they're molecular. Right, so we're not talking ionic or anything else. We're talking about molecular compounds. And one has a boiling point at negative 84 degrees Celsius, and the other one has a boiling point at 34 degrees Celsius. Question A, and that's at normal boiling point. So under normal conditions, meaning 1 atmosphere. We want to know which of the statements are correct, and we want to fix the ones that are not correct. So the first statement says that the higher boiling liquid has the greater total intramolecular forces than the lower boiling liquid, and that is correct. The more as you increase the intramolecular forces, both in number and in strength, then you're going to increase your boiling point. The stronger the intramolecular forces, the more forces that it can form, intramolecular forces that can form, the higher the boiling point. So this is correct. B states the lower boiling liquid must consist of nonpolar molecules. And that's not necessarily true. They might both consist of nonpolar, they might both not. What is true is that the lower boiling liquid, remember, it's all about intermolecular forces. So the lower boiling liquid must experience either fewer intermolecular forces or weaker intermolecular forces. Question C says that the lower boiling liquid has a lower molecular weight than the higher boiling liquid. And again, that's not necessarily true. However, if both liquids have similar molecular structures, if they both have similar structures, then it is true. Then the lower the molecular weight, the lower the boiling point will be, because molecular weight is going to affect the polarizability of the molecule. The less polarizable it is, the weaker the intermolecular forces, the weaker the London dispersion forces are. Question D says, why is the the two liquids have identical vapor pressures at their normal boiling point, and this is correct because by definition, the normal boiling point is the boiling point at 1 atmosphere or 760 millimeters of mercury, and the boiling point is also the point at which the vapor pressure is equal to the atmospheric pressure. So if we're at the normal boiling point, then we are at 1 atmosphere, and therefore the vapor pressure is 1 atmosphere for both of them. And then finally, E says at negative 84 degrees Celsius, both liquids have vapor pressures of 760 millimeters of mercury. And that is not correct. At their normal boiling point, which is only negative 84 degrees Celsius for one of them, but at their normal boiling point, that's when they both liquids have vapor pressures equal to 760 millimeters of mercury, which is normal atmospheric pressure.